Hello, everyone.
Hello.
Welcome to this webinar. Well, hope that you can hear us and see us well. Hope that you're having a great evening. Okay, you should be able to see an opening poll. Please feel free to answer that question. Meanwhile, I think we can start this webinar. So we'll just introduce ourselves. I'm Răzvan, Chief Solutions Architect in Yonder. I have been working here for more than 11 years, and I had the chance to develop applications in all major technologies, starting from .NET, Java, Python, to front-end technologies in JavaScript and TypeScript. But I've also been involved in developing applications in different platforms, from desktop to mobile and cloud. In the past years, I would say that my role in Yonder allowed me to be very active in the initial phase of collaboration with the customers. It's actually the fun part where everything is being planned, decided, and starting from the architecture, technology stack, the tooling, and also the way of working. And together with me, it's my colleague Călin, if you'd like to introduce.
Hello, my name is Călin. I've been in Yonder for 5 years. Most of my time I've been working with Java-related technologies, and I've been in decision of choosing the right technology for the right application. So that's how I, together with Răzvan, we made this presentation to also help you guys to choose the right, to have the right decisions. And also to cover some aspects of this onion architecture.
Thank you, Călin. And now let's, because you, now that you know us, let's also see what kind of experience do you have with the onion. Good. So it looks like a large part of the audience never experienced with onion architecture, and you're eager to find out more about what it is. So that's really nice, because basically, we are going to talk about onion architecture, and this presentation is actually being designed for seniors, for tech leads, but mostly for decision makers, maybe at the beginning of a new project or a new module. And we don't want to get into too many technical details, even though there will be some slides that contain code, and I'm sure that you developers will enjoy those snippets of code. But there will also be some kind of diagram, which I hope it can describe better what kind of challenges onion architecture wants to solve. So the way we are gonna approach this presentation, basically we'll start with a bit of context, mostly how layered architecture evolved over time. And then we're gonna go through some details of what is onion architecture in theory. Of course, the theory is not the same with the practice. So if you later on decide to use the onion architecture in your application, most probably you will have to choose how some of the cross-cutting concerns will work. So we are going to spend a lot of time in this area because we want to share with you some or a few practical tips that hopefully will assist you to make better decisions. And of course, at the end, after we provide you those practical tips, then we are going to have a look at 2 real-world applications that we had in Yonder. And those 2 projects were actually being implemented using different technology, and hope that it can create you a better, it's going to give you a better overview of how onion architecture can be used. So let's move on to the initial part, where it's a bit of layered architecture history. So if you look at any application that was developed like 20, 30 years ago, most probably it's going to have the most simple architecture. So It's going to be a client-server app where the server is also the database. Most probably inside the client application, there is no separation of concern, meaning that the application screens, the pages or views, will have the logic of calling the database, of apply validations, of updating the API, the UI. So basically contain the entire business logic together with everything else. And this is causing some issues because that particular code is hard to reuse, to change or maintain, right? So to fix that, the multi-layered architecture can be used. And the main principle is actually to separate the concerns in different layers. And usually the way you are going to approach that is that each one of the layers is going to be part of a project or a package, and that there will be some kind of dependencies between them. So you can see at this moment that, for example, the presentation layer has a dependency to the business layer, and the same thing to the business layer access to the data layer. Now, this has two benefits. Is that one of them is that you can reuse some of the layers. So if you look at the data layer, basically, if you want to actually reuse in a totally different application and have the same storage mechanism or maybe the same physical storage location, then you can just pull that data layer and reuse it whenever you want. Or if you want to switch the top layer, the presentation layer, which it might happen more often than reusing the data layer. For example, if you're on .NET, you might want to change from Windows Forms to WPF or things like that. Then you are going to be able to do that. You just replace the presentation layer, and then reuse the business and the data layer. But still, you're gonna, we can say that there is still a challenge because it's hard to unit test the business layer, which is the most important part in the application. It's hard to unit test it without hitting the real database. And usually the way you're going to handle this is by just creating an interface, just create some abstractions. For example, here there will be a person repository interface, and then the business layer, the person service is going to use that interface. So having this kind of approach basically enables the person service to be unit testable, and just by mocking this particular interface. So it brings a lot of value. However, there's still one of the issues. There's still some issues. One of them, it might be that, okay, the data layer is still not swappable, and more than that, the data layer itself somehow detects or dictates the way the business layer is going to be implemented, right? So if you want to change something, then you're going to somehow have to refactor the business layer. Now, the final solution does not actually come very naturally to developers, because usually we as developers, we tend to design the applications or the layers based on how the data flow goes through the app, and not based on the dependency between the business logic and the infrastructure. So usually we are gonna, the way we look at it is that, okay, this is the data flow, but not based on the dependency. So it's just a simple concept of, instead of having the interface located in the data layer, you just move it one layer up. And because of that, the repository is going to implement the interface, which is located inside the business logic. So this brings a lot of value, because now you can see that it's just a reverse dependency. And then all the projects will depend on the business layer and not the other way around. And we can say that the only dependency that the business logic has, it's just the language in which it is implemented. So I hope this can create a bit of context of how a layered architecture evolved over time. But now let's get into more details about, hey, what is an onion architecture?
Yeah, so if you just zoom out a little bit, the diagram that Răzvan showed you, you have this domain logic in the center of the architecture. If you see the flow control, the method call is the same as a layered architecture. So it's not different from a layer architecture. One thing that it's important to mention, and probably you'll find, if you just Google Onion architecture on Google, you'll find this architecture with different names like Onion, Clean, Hexagonal, and ports and adapters. And as far as I know, each one was invented by a different person, but and they have like some differences, but small differences, but they share the same idea, is to isolate the domain from external agencies like the presentation, infrastructure, or even your database. So using the dependency inversion, like Răzvan showed you with that interface and abstractions. Okay, so when we're talking about every software concept, you'll always find some trade-offs. So the goods or the bads, like the title of the presentation said. So the advantage of a hexagonal is, as you saw in the previous slides, is the dependency of the domain. So your developer should focus only on the business logic, only on the domain logic, and the domain logic should be independent of any framework, if it's Spring or Quarkus or whatever, of the database. So it doesn't matter if it's SQL, NoSQL, and also if you have like external services or queues or whatever. One advantage that I find in hexagonal architecture, and it's very underrated, it's easy to test the domain logic. So that's a good point for a hexagonal architecture. Now, everything comes with also with some disadvantages. So your developer will write a lot of boilerplate code, and it's not suitable. Maybe your project is a small to medium project, and as a developer, you'll find that you'll write a lot of interfaces, a lot of duplicated code around the persistence entities and domain entities. You also have this middleman code smell. It's like you have like strict constraints, like your controller should call a service, and a service should call a repository. And this happens also if you have like a simple code, just one line, one get from your database. So it's boilerplate. And also developers should be should have a lot of discipline around it to maintain it on the long run. Now, we talk about a lot of theory, we showed you some diagrams, but when you start developing, you'll find that you need to share your data to the UI. You have a lot of flavors in the database, a lot of technologies around this, your domain logic. And in the next slides, we will try to present you some implementations that can be used in the around the Onion architecture, and how we can deal with that and how integrate with this architecture. So first, let's talk about the center of the architecture, which is the domain. This is the most important, and you should have like a high priority on this center of the architecture. And the question is how you structure the domain logic. And there are multiple ways, but the two most popular are the following. So it's the transaction script, where you have your domain entities with just getters and setters. So they're like just some data holders. And these data holders will be manipulated by a service. A service is just a procedure. It's not object-oriented, and sometimes I don't think it's important, because the business is more important than how you write your code. And it's very easy to map your business procedures. The second approach is more complex and more hard to learn, is the domain-driven design, where you have like rich entities and maybe some small services. But this will require a lot of deep business involvement from developers The main advantage of this one is that it's very high maintainable on the long run. But as we experience, and we found that the transaction script is much simpler and more suitable for developers, and it's very easy to learn it because it's just procedural code. Now you designed your domain logic structure, so the center of the architecture. Then you start exposing your data. Maybe you have like a lot of web clients that will consume your data, or different devices, mobile, watches, and so on. And one important thing to mention is that user interfaces has different purposes. They will not match your domain entity data. They want data to match their needs. So like in this example, we have just a simple table, and you have like compose fields, a lot of aggregations, maybe more items to be aggregated. So what we recommend here is to never expose your domain entities into the presentation layer. Instead, try to use a mapper. So a mapper will just aggregate multiple domain entities or fields or whatever, and create a specific DTO, data transfer object, for that view. So this allows you to decouple your domain entity from the presentation layer. Now, the question is where you put this mapping, and the answer is we recommend to use a facade. I think it's also called an application service. It depends if you like to call it facade or application service, but the main idea is to have like a class that is responsible for this DTO to domain entity mapping, maybe to validate against some user inputs. Maybe you want also to apply some cross-cutting concerns like logging, some aspect-oriented programming. The second role of this class is also to orchestrate. So for example, you probably have like a single domain use case, and in order to complete this domain use case, you should use multiple domain services. So with this facade, you can orchestrate multiple domain services and delegate to them. And this is also can be done using a transaction. So a facade role is also to manage transactions. Now, this is related to the disadvantage that I mentioned in the previous slides, is the middleman code smell. So you probably had this experience, like having multiple layers, and you just write one line of code to each one because you want to respect a structure that is imposed by your architect or your tech lead. And you find that is very frustrating. And that's why we recommend to using this approach is to start implementing everything in facade. So you can also skip some layers. And we also provide you an heuristic that you can follow when using a facade. So if you have like the requirements, you start implementing the logic. So you model your domain entities and start implementing everything in a facade. Then when the logic gets complex or has to be reused, you just extract them. So it's a continuous extraction into separate domain services. And like I mentioned, the facade also orchestrates these domain services. But if it's something that is very simpler, like getting an entity from your repository, you can just call directly in the facade. So there's no need to go into a domain service. Now, speaking of repositories and databases, if you follow the Onion architecture by the book, maybe you had this question: should I map my domain model into a domain persistence entity in the repository layer? And the question is yes, but you need to assume the following thing. You'll have a lot of duplicated properties. You probably need to implement, again, a mapper inside the repository layer in order to convert your domain into a persistence entity. And that's why we came with two recommendations. So you can relax a little bit the constraint, and you can use the persistence entity as your domain entity, but you should have the following prerequisites. So you need to control a database structure. Another thing is you don't need to change your domain to fulfill your database needs. And the main advantages of this approach is that you don't need you will not have duplicated properties. And this is very useful when you have like small to medium projects. Now, the second approach is to separate them and to write some mappers and to duplicate some attributes. And we recommend this approach if you have a legacy database or if your domain entities evolve in time differently than the persistence entities. If you have this in your application, then try to find a way to separate them.
Yeah, the way I like also to look at it is that in case you have, let's say, a database first approach, well, in that case, you might want to go with this approach. But if you control everything like migration, and then you can also have this rule in place to reuse some of the entities. Good. Now imagine like inside your domain service, you might want to have some information about the current user, the current tenant, or any other type of cross-cutting concern. And in order to achieve that, the guideline is to create, again, something like a context provider interface, for example, the user session is, and then outside of the domain, you can implement it maybe inside the application. And here is the logic where you get the user session or the tenant, or maybe have a so-called date provider. This is very important in case you want to have a fully unit testable and not rely on the date time of running the unit test. So usually you'll have this interface inside the domain. However, what we recommend is to create a so-called core layer, which sits between the domain and application. Actually, this is more like a ports interface, but we call it core because it's part of the cross-cutting concern layer, and you can extract it. This layer can also be reused for multiple onions in case you have them. And in this way, you can just pull information about the user or the tenant. Now, another cross-cutting concern that can be solved either by making a facade outside, or maybe if you needed to create a transaction scope inside your domain. So have a look at the example that we have here. Is that we need to have some access to a particular from different repositories. We need to pull some information. We change both of those items, and then at the end, we want to save changes. Now we want to do this in a transactional way, meaning that in case the second one fails, also the first one should fail. And in order to do that, you need the mechanism to create a transaction scope across different repositories, right? And the only way, or there are multiple ways, but the ones that it's very popular and we recommend is to use so-called a unit of work concept, where for sure, again, this is an interface, and you might have something like a factory that can be used whenever you want to set the border of the transaction. And then this one, every time you say, hey, provide me a unit of work, it's gonna return an implementation of this interface. And that's the way you can basically get information, get a repository instances, and then also in the end you can persist changes, like save changes, which will be inside that particular transaction. And of course, this is again in the interface layer. and then you have to implement, depending if you're using, for example, in .NET Entity Framework, then you'll have some kind of implementation here. If you use Dapper or something else, then you will be able to implement this inside and make sure that you're reusing the transaction that is being created while you call for this create method. So that's one way to do it. And now what we also want to get into more advanced, which it can get quite popular. It's about the keeping a separation between onions. So imagine like you have 10 onions in the same application. In our case, we have just two. One of them is called catalog and the other one is called basket. So what happens if, for example, from outside of these particular two onions, you want to update the price? Basically, you're going to call the product service. And there are two ways. I mean, the simplest way will be to just create a dependency between these two onions, right? And this is not something that we recommend. We don't want to have dependencies. They should be standalone. And in order to have this communication between this layer, there are two approaches. The simplest one might be to have something like a mediator implementation. So using mediator pattern, where you're going to have an interface which sits inside the catalog domain. And then outside of it, you're going to implement it in the application layer. And whenever, you know, the price has been updated, basically you're going to call the basket domain in order to update the price inside the basket, right? That's the simple approach. Or you can go with more advanced like pub sub pattern, where you're going to have outside of it, you're going to have something like a message bus. So basically when a product is being updated from the product service, an event will be published. We call it price change. And now every other onion or domain that wants to subscribe to that particular event and react on it, basically you can just have a subscriber. You're going to subscribe for that particular event, and then you can call the basket service, right? So this is very handy, mostly if you have multiple onions that you want to react for that price change. Here is more like if you just have two of them, then you might want to go with a mediator as well. Good. Now, this is we share with you some practical tips. Now let's have a look and see how everything comes together into real world applications.
So we started an application in Yonder together with some clients from Canada. It's an oil and gas planning platform. Right now, it's a small to medium size application. We started with a low knowledge of the domain and learn. Another, let's say, prerequisite for our decision to choose the hexagonal architecture or onion architecture is that the application required some integration with an existing application. In terms of technology, we used Spring Boot, REST API, and Angular UI. And as for database technology, we used the Postgres, SQL, and JPA, Hibernate, and Spring Data. So if you're going to the next slide. So this is a high-level architecture of our application. As you can see in the middle of the architecture, you see the core package or the domain package, which will contain domain entities. The first relaxation we have is that we use the domain entity is the same as the persistent entity. We put just some JPA annotation on that. And the reason why we did that is that we observed that in time that we just duplicated the properties from domain to the persistent entities, and that's why we took this decision. We also relaxed a little bit also the modules. So instead of having the infrastructure and application and domain, you just have two modules, the domain and application, or the core and application. And the reason why we choose that is in order to call directly in the facade, to call directly a repository, or maybe also a JPA query or something like that. So the core exposed some ports. We borrowed this term from the ports and adapters. So if you want to implement a repository pattern, or just implement declare an interface report called the repository port, and then let the technology adapt to it using the dependency of inversion. The controller will call the facade. In the facade, you'll have the DTOs, the mappers, and yeah, that's all.
Great. And if it is to look at an example in .NET, in this case, we have a customer from USA. It was in the shipping industry. Now, what was changed from Călin's use case is that this was an existing application. It was a mid-size old desktop app. Now, the idea, the thing about it is that it was also using as storage. The entire data was being stored in XML files. Now, the plan was to migrate that particular desktop app into a web application, and but also reuse some of the existing features, which means that we should also reuse the data layer behind those existing features. And the new features should be in storing data inside a relational database, which is MariaDB and Oracle in that case. And later on, with the idea that we will also migrate from XML to the relational database. And we also had to keep in mind, because while they are migrating from on-premise to SaaS, later on they might want to have some so-called multi-tenant support. So if it is to have a look at oversimplified version of the diagram that they had, so you can see that in the middle of this onion is the domain with a few services and models. And what is really nice is that this domain does not have any other dependencies besides the ones from core, and so which contains only interfaces. The thing that we also agreed is that even though these repositories are related to this particular domain, we decided just to move it outside in a separate project, so that whenever we want to have an implementation, we just use that particular repository without having to have a reference between the data is directly to domain, just to the repositories of that particular domain. Now, what is really important to mention here is that you can see this domain is being used by two projects. One of them is actually the REST API, and the other one is the unit test. And inside these two application layers, because we can also consider the unit test as an application, basically you can see the inversion of control. So the configuration of dependency injection is being inside of each particular applications, meaning that in case it's a REST app, we can use the real implementation. If it's a unit test, then we can just provide mock implementations of these interfaces. Now, we've also used the context provider that were implemented for the app. And then in order to have the data access, what it's nice to mention is that here this is the part that we actually use from the old desktop app. So we created a repository that was calling that one. And of course, that one is actually swappable. So in case we want to migrate from XML files to a database, we will create a new implementation of this particular repository and of this particular repository. And this one is going to go through MariaDB or an Oracle. And then what we are going to do is just obsolete or deprecate or remove these dependencies, right? So it will be very easy to achieve that. And by the way, while we are creating a repository, a new interface of implementation of that particular interface and deprecating these layers, we don't even touch the domain, right? So it's gonna be this part, it's not gonna have any kind of change. Good. Yeah, I think our time is up for presenting. I'm really curious to see what are your thoughts after you see this presentation. So now you should be able to see another poll please feel free to provide us feedback and see if now if we created more clearance, let's say, of what Onion architecture can do. Meanwhile, I think we can, by the way, please ask any question. If we have something like 10 minutes for Q&A.
We have Răzvan one question.
Oh, okay. Hold on a second. Okay. Oh, so there is one question from Vlad. Why wouldn't you call directly the service from Onion to the other? Also, how can I end up with multiple onions in one application? Sure, if I go back to this particular slide, yeah, it's not a good idea to have these dependencies, right? Because now you will have a dependency in this way, then you're gonna have in the other way. Maybe later on you will have other onions and again some dependency. So you can already notice that it can get it can create spaghetti code, first of all, right? And more than that, it's not just spaghetti code, because you have multiple domains that depend on each other, or at least the domain services that depend on models or things like that from the other onions. You will get into so-called monolith, and it's not a good idea. Separating those domain means that later on, if you want, you can have something like a total separation, not logically, but also from the physical perspective. So you can get into so-called microservices where you just, provide more like here, you just put it in another application. And then in this case, you can collaborate between multiple microservices using so-called a message bus, right? So it's really important to have a separation of the domain, because it allows you to remove it to a microservice, but it also because you avoid the spaghetti code and yeah, and you will be staying away from the monolith part, right? I think that answered your question, and I think, oh yeah, the other part was, how can you end up in multiple onions in one application? Well, it depends. Usually you have multiple modules. So you'll have something like, as we had, the catalog, where you keep all the items, all the products that you want to sell. You have the basket, where when the people are buying it, you have the reports, so usually you have those kind of bounded contexts that can be separated. And we don't recommend having them together, because yeah, you're gonna create some kind of spaghetti code. Anything you want to add, Călin, about that?
No, I just wanted to read the second question.
Yeah, please.
So Călin asked, are there any tools that help developers to maintain an Onion architecture on the long run? Yeah, so for example, if you're starting a project with this Onion architecture, or having an existing application and you want to refactor to an Onion architecture, I recommend to extract into separate modules. And I mean, depends also on the language and the framework, and it should support modules. If not, or again, if it supports, and you can also, on top of that, can add some tools like I think in Java, it's called the arch unit, which allows you to write unit tests and where you can describe your architecture, how it looks, what are the boundaries of each modules, and so on. And yeah, this will keep also the developers not to bleed the wrong modules with the wrong classes. So yeah, I think these are the tools that came to my mind right now.
Yep.
The third question is, are there projects you will not apply Onion architecture? Yes. So again, software is full of trade-offs, so I will not recommend Onion architecture for everything. If you have like small application, more like crude application, use a simple architecture like Răzvan showed you in the previous slides, like a layered one. Maybe also to look into technologies like OData or Spring HTOAS that allows you to communicate directly from your REST controller to your database using some framework technologies. Yeah, so that's my answer.
Yeah, and I also want to add the one more type of application. I feel that, you know, having really small apps like serverless applications, well, it's so small that it's not going to be an issue to maintain that one, or it's not going to be hard to change or to swap. So it's really not worth to use this boilerplate around the domain just for that particular application. If it gets a bit larger, well, in that case, it makes sense to create this kind of rules that allows you to maintain better when it gets bigger, right? Good. If I have a legacy application with ad hoc architecture, what would be the best way to refactor it towards an onion architecture? Wow, that's a tough one. So I believe when you're referring to ad hoc architecture, means something like an architecture where it's more like a monolith, or if it's especially an application where you have everything inside the presenting mode, it's going to be quite hard to refactor that one. Maybe it will be worth to not do anything. The first thing, so maybe you can just keep it like that and try to create around it some other applications, or somehow try to refactor it.
So applying the strangle fig pattern.
Yeah. Maybe that will be another idea. So maybe you just want to, instead of trying to refactor the existing code, you start with some modules that you feel you want to add new features, and then based on that, you can decide, okay, should I go to the old implementation or to the new implementation? So having this in as an option, it's also a good idea. But if everything is a mess and it's quite hard to refactor it, I'm not sure if it's a simple fix to that, or the simple solution. Good. And I think we have time for one question. Would you recommend to start with onion architecture when MVP POC started, or to adapt your implementation after the MVP? What is your thought, Călin, on that?
I think it depends on what you want to achieve in your POC or MVP. You can also have like a throwaway solution and just to validate some ideas and throw away and rewrite again. But this also depends on your budget. Or you can also start with a layered architecture and adapt it to onion. But again, when we're talking about hexagonal architecture, which will have a lot of boundaries, you need developers with a little bit of discipline in order to do that.
What I would also add is that for me, a POC means that you validate the items with the highest risk, right? And now, of course, one of that particular item, it's actually the onion architecture. Well, in that case, you need to prove it. So you are going to start with creating some different use cases of, hey, what things I would like to have in place? Okay, the access to the database and also the layer. And when we say that you want to prove inside the POC that the onion architecture is a good fit, so that's actually part of the POC. Basically, it means that your application is very business oriented, and the highest thing that you want to prove, or the biggest thing that you want to prove in this POC, it's actually the fact that it's unit testable, and you make sure that it's going to be highly maintainable. But if, for example, it's just there are other things that you need to prove in this POC phase, I would not bother starting with this in mind. I would, because it's a POC, you might want to validate the performance. You might want to validate the deployment, the authentication. So those are the items that you should focus on, not on, okay, the discipline of the developer, so having the interface inside the place and things like that. Good. And would you apply Onion architecture to single page applications? That's a good question. So I believe, Vlad, you're asking if for the single page apps.
I think it's only Angular. I don't know if you can do that.
Yeah, on Angular, but yeah, again, now we are talking about Onion architecture to protect the business logic. But for the front end, I feel like it's not business logic, right? It's more like presentation logic. It's just the UI logic. So having this in mind, having this in trying to have Onion architecture on that, I think it's not going to worth it, because Angular already is has its way of doing things. If you try to override it, well, it's not going to work well. I think we have to stop here, because the next meeting is going to start soon. And hope you enjoy this talk. And yeah, see you in like 14 minutes for a webinar about when to plan performance. Have a good evening. Thank you.
Thank you.